Okay, this video is on limits and continuity, so answer the following questions on each of the limits given. Limits of the given function as x approaches a certain value and show clear and logical work. So number one is when x is approaching infinity. So for these ones, obviously if you plug it in, you're going to get infinity over infinity, right? So in those situations, there are certain rules that you can use. So if the leading term degree of your denominator equals the leading term degree of your numerator, then you can take the ratio of the coefficients of the denominator and the numerator, right? So since they're equal, like the leading term is 2, so degree is 2, our limit is going to be equal to 4 over 3, okay? And then, well, this is pretty simple. This is just using the rules, so there's nothing really much to need to show. Okay, and number 2. This one is actually approaching a value. Let's try to plug this in. That's our first step. So if you plug it into the denominator, it becomes 0, and then 3 squared minus 15, negative 6 plus 6, it's also 0, so 0, 0. The key here is to never use the equal sign because mathematically that's an incorrect notation. So, I mean, this is indeterminate form, and that's not equal to this, right? You can't really make something indeterminate equal to something else. So we can't use an equal sign, but just make sure that you plug it in and show that you plugged it in. Okay, and then what do we do here? For this one, we can try to factor. So equals limit of x negative x to x approaches 3, x minus 3 times x minus 2 all over x minus 3. You can cancel that out, so we get limit of x approaches 3, x minus 2, or when we plug in the 3, we get 1 as our answer. Okay, and then moving on to number 3. This is, again, x approaches infinity. So for this one, we notice that the denominator degree is greater than the numerator degree. So since the denominator is growing at a much faster pace than the numerator is, we're going to say that this is equal to 0. Right? This is another rule that I mentioned in number 1. Okay, and then number 4. Limit as x approaches 4, and then 5x minus 20 all over x minus 4. Okay, plug in 4 again, we get 0, 0, right? So again, we're going to try to factor this out. So limit x approaches 4, 5x minus 4 all over x minus 4. We get limit as x approaches 4, 5. So we just get 5, right? Okay, this is our limit. Alright, so for this example, we're going to be using something called conjugate pair. So that's because we have a limit as x approaches a certain value of a radical, and then we can try to cancel the radical out to simplify. So first, plugging it 6 into the equation, so you're going to get 0 over 0, right? So it's an indeterminate form, so that's why we have to do something else. So this is equal to limit x approaches 0 of x plus 19 minus 5 all over x minus 6 to the power, and then times conjugate pair, which is going to be x plus 19 plus 5 all over square root of x plus 19 plus 5. I mean, this basically is algebraically equal to 1, so it doesn't really make a difference in algebra terms, but then there is actually a difference when you're multiplying these two together. So basically, conjugate pair, you're trying to find the value or multiply a certain radical with another one that can cancel out the radical and then ultimately produce an easier result. So that's what we're going to do. So as limit x approaches 6, x plus 19, right, minus 25 if you multiply these two, the top numerators, and then all over x minus 6 times square root of x plus 19 plus 5. Alright, so we're getting limit as x approaches 6, x minus 6, and then x minus 6 times x plus 19 plus 5, right? So this part cancels out, right? This is a common factor. And then we're going to be left with limit as x approaches 6 of 1 all over square root of 19, x plus 19 plus 5. And then if you plug 6 in, you're going to be getting 1 over 10 as your answer. And then number 6. it's also a radical, but for this one, we can't really multiply conjugate pair, right? Because there is no conjugate. So what we do here is that we notice that we have an x squared inside of a radical, right? And obviously, you can, in limit problems, because these leading terms are going to be so much larger or growing at so much larger pace than these like constants, we can kind of ignore them. So we can say like, we don't have to put an equal sign, but we can say, we can view it as this all over x, okay? So honestly speaking, this is basically just limit of x approaches infinity, and then root 3 times x squared in a root, right, all over x. So, well, x squared is inside root, so that means that limit of x equals 0, root 3 x over x, right? And it's basically like, you can kind of cancel it out, right? And then that gives us root 3. What you can think of this is like, you can think of this as like an x, right? You can say that the numerator and the denominator both have x as their leading term. So that's the degree. Degree is 1. So you take the ratio of it, which is basically root 3. Okay. Number 7, we have this one. We have an infinity again. So since the denominator is much larger, or growing at a much larger pace than the numerator, we're going to get the answer of 0, right? Okay, and then we have a conjugate pair one more time. So let's see, limit x negative 4, and then we're going to multiply x squared, x plus 5 and square root plus 3 all over, okay? Which means limit of x approaches 4. And then let's try to figure out the denominator first. So x plus 5, right, minus 9 all over x squared. Okay, and then minus 6x plus 8 times root x plus 5 plus 3, right? Or limit as x approaches 4, x minus 4. Okay, and I forgot to do this in the first step, but make sure you plug in every single time. If you plug it in, you get 0 root 0. Okay? Yeah. And then, so you get x minus 4 times, and you can try to factor this, right? You can do x minus 4 times x minus 2, right? To get the polynomial. So you're going to say x minus 4 times x minus 2 times root x plus 5 plus 3, right? Or we can cancel this out. So limit as x approaches 4 and x minus 2 times root x plus 5 plus 3, right? And then we're going to plug this in. So that is 2 times 6, right? Or 12 will be our answer. And then now we have limit as x approaches positive 3 all over x minus 3. Okay, let's try to plug this in first. So we get, if you plug in 3, we get negative 1 all over 6, not 6, 0, right? Negative 1 all over 0. But then something that we need to keep in mind is that in this case, x is approaching from numbers greater than 3, right? So it's approaching, like 3 is right here, and it's approaching from somewhere bigger than 3, right? Where the x value is somewhere bigger than 3. So that means that it's going to be like 3.00001, right? And then that minus 3 is going to give us with the positive number, right? Rather positive number. So this is going to be positive 0. And that means that since there's a positive on the numerator and a positive on the denominator and a negative on the numerator, we're going to get a negative infinity, right? But if we did have like something like 3 minus, so approaching x from like somewhere smaller than 3 as an x value, like 2.99999, then we're going to get a negative like denominator, right? Since we're doing 2.999 minus 3. In that case, we're going to have negative 1 all over negative 0, or not negative 0, but like, you know, it's kind of approaching, I would say it's, you can say that it's like a negative 0, but it's not really negative 0. It's more like a little bit less than 0. Yeah, so that's gonna give us a negative infinity or positive infinity, right? Yeah. Okay, so for this one, the answer is going to be negative infinity. Alright, so in number 10, we have limit as x approaches 0 of sine 3x all over 5x, right? So there is a known limit property, right? And it's when limit as x approaches 0 of sine x all over x is going to equal to 1. So this is only valid if the x here is like the x in the numerator is the same as the x in the denominator, which is not the case of number 10, right? Because we have 3x in the numerator and then 5x in the denominator. So something needs to be done algebraically to correct it. So yeah. And then before we do that, if we plug in 0 to both the numerator and denominator, we get 0 over 0, which is indeterminate. So limit as x approaches 0, and I'm going to separate this 5x, so it's going to be 1/5 times sine 3x all over x, right? So we're going to have 1/5 limit x approaches 0 of sine 3x all over x, and then we're going to multiply this by 3 over 3, right? 3 over 3 is essentially 1, so there's not really a change, but then it makes an algebraic difference, so that this part is going to combine to 3x. So we're going to put this right here outside, so we're going to have 3 over 5 limit as x approaches 0, but we're not going to do 3 over 15, right? We're going to do sine 3x all over 3x to match the denominator, the numerator, and the x terms, so that we can use our limit property. And then since this part is equal to 1, 3 over 5 times 1 is going to be 3 over 5, so that would be our limit.